Going live. Good morning, good afternoon, good evening, everyone. Welcome to today's webinar. It's 10 p.m. Do you know if your application is secure? I don't know how many of you remember those old commercials, but we thought it was kind of fun and it'd be fun to talk about application security with you today. I have with me today Wilhelm Hocker. Wilhelm and I have worked together off and on for quite a long time. Say hi, Wilhelm.
Yeah, hey everybody.
So we've got some interesting stuff today. We're going to talk about some important issues for security. For those who don't know us, we're Parasoft. We've been in business for over 35 years. We've won a bunch of awards for various things. We'll send this deck out afterwards, so if you have any issues, don't worry. And the recording, you'll get a link afterward that'll you'll be able to share with your friends and things like that. And if you have problems with this, like if something weird is going on, and first of all, there's a question box, so ask questions and we'll try to handle them either at the time if they're really timely, or we'll handle Q&A at the end. But if you have issues, one of the sort of simplest things is to refresh your browser, and maybe that'll help you. So just a hint ahead of time. So the basic topics we're going to cover today are security problems today, how to know if what you're doing is secure, right? Where am I at? We could talk a little about API security because it's tricky and it's a part of the big problem today. And then we're going to talk about dealing with, you put all these efforts together to find security issues. So we're going to talk about how do you deal with that, and how does AI ML work on the good guy side, right? On the white hat side. Now, we know that over the last couple of years, especially, everything's online now. We did this rush of digital transformation when lockdowns came around the world. And because of that, more things are online, but also we may have skipped some due diligence in putting things online. And so there's a lot of exposure. And for anybody who follows the news, we're seeing, breaches, failures, hacked accounts, compromises, an unending stream of stories. If you put a couple of keywords into a Google search, you'll see these things happening on a regular basis. And there was an interesting report recently put out by Imperva about quantifying the cost of API insecurity. And 12 to 23 billion annually in API related cyber loss in the US. Globally, 40 to 75 billion, right? And the average annual global insured loss, 200 to 375 million. So it's a pretty monstrous problem. Another hint that Joy just let me know, right? Like when you're watching, if your screen is blurry, you can always adjust your BrightTalk settings on your end and adjust your resolution. So if there's issues there, you can do that. 25% of the cyber events were API insecurity. So API is the elephant in the room, and we're going to talk about that a little bit. But the first question is, do you even really know what's going on in your application? With that, Wilhelm's going to show us some cool stuff.
All right, so let me get things shared over here. Okay.
Let me cover that spooky Jack in the Box. It's meant to represent bad things that pop out of your application.
All right, here we go. Arthur, can you confirm my screen is being shared? Perfect. Yep. So, as Arthur said, do we even know what's happening? And the thing is, catching or detecting hacks is one thing, but what about preventing them, right? Organizations that are heavily invested in protecting their digital assets and services, they need to take a close look at application security, really across the enterprise, plus having the ability to drill down into specifics down to the code level. So here, what I'm showing you is Parasoft DTP. This is the heart of Parasoft's continuous quality platform. And here is where you'll see dashboards that can be tailored for high-level views suitable for VPs and managers, or lower-level views more suitable for dev leads and Scrum teams. And so this first dashboard I'm showing you here is one that illustrates the ability to design a high-level overview across a portfolio of programs or projects where the focus could be AppSec, it could be quality or performance, or a number of other technical KPIs that are associated with software development. Today, we're focused on security. So you can see at the top here, I've got a row of widgets that tell us the compliance status for a variety of projects, like there's the Quartz project, here's Parabank, um, against popular secure coding standards like OWASP or CWE. And the thing about these dashboards, you can add and subtract widgets as needed. You can move them around, and then really just kind of tailor them to or curate them rather to exactly the view that you're looking for. So now let's say that we don't like what we see with the Parabank project, right? 40% OWASP compliance. So let's take a look, a little closer look at that project. So I've got another dashboard here that I've created called Parabank Security Review. And here I've customized this to illustrate the details that one would be interested in, maybe more at the project level. And the data that's populating these dashboards, it's coming from automation. So code scanning and penetration testing are being performed with every build of the code, and results are being published to DTP. And so this is why here in the first widget I've got files changed, so we can see exactly what changed between a baseline build and a target build, which is the basis for some of the analytics we'll be looking at today. Next, we can see I put some widgets in place for Parabank's compliance status across OWASP, CWE, PCI DSS, popular standards that our customers care about. And then for our government customers, you might be interested in knowing that we've also got a SAST rule set that maps to DISA ASD STIG. And we're going to come back to drilling into some of these widgets and looking at more details later. But let's look and see what else we can learn about this project from a high level. So down here, I've got a trend of violations where we can see over 5,000 violations in this project after I kind of turned on all the different standards that we care about here. And nearly 2,000 of them are Severity 1 and Severity 2. So, not what anyone really wants to see if this was their project, but pretty common, I'm afraid to say, when we work with customers whose projects haven't really had compliance as a requirement from day one. Next, over here, we can see that DTP also integrates with the OWASP dependency checker, which is a software composition analysis tool that attempts to detect publicly disclosed vulnerabilities contained within a project's dependencies. And so here I can see that Parabank, right, we've got 10 vulnerable dependencies that are Severity 2, right? These libraries should get updated as soon as possible so that, we don't introduce any leaks, not from our code, right, but from code that we're using open source libraries that might have some security weaknesses in them. Now, on the bottom row, here is where I've got results from API security testing, also known as API penetration testing or DAST. And this type of testing, we often see it getting put off until code is promoted to an AppSec team's environment, closer to release than you would like. But here we're seeing automated pen testing that's been adopted by development and QA, right? That's being run with every build in their pipeline, which I'm going to be talking a bit more later on in the presentation. So We've gotten a couple bird's eye views into application security where we're seeing data from a number of DevSecOps practices brought under a common view. So, Arthur, I'll pass it back to you from here, and you can take us forward.
All right. So I did want to talk about a couple of the standards that are out there, and those who've spent any time in this know that there's a whole bunch of different things. There's the NIST 853, which lots of people are aware of. UL's got a cybersecurity. The bar group's got things. PCI DSS if you're dealing with credit cards. OWASP, hopefully everyone's heard of it. It's the Open Web Application Security Project, and it's a nonprofit, and so you can use their stuff free for nothing, which is kind of cool. CWE is a U.S. government-led initiative for common weakness enumeration. A lot of people who've spent time in the security engineer side of the world are familiar with CVE, which is things that get found. Like when you were talking about that, Wilhelm, a moment ago about composition analysis, right? If somebody finds an issue in log4j, then it gets published as a CVE. And there are some CWEs that are what are the problems in the underlying source code that relate to it. So there's a whole bunch of different coding standards, unfortunately, because it can make it tricky and confusing. And in fact, the tendency when people try to repair this is not to unify around a single standard, but to join, to create yet another standard today. So unfortunately, that's the world that we live in today. I would say that the most common standards that we encounter in the security space are OWASP, CWE, and CERT. We do see OWASP a lot, especially in the beginning, because it's free and because there's a lot of information from OWASP oriented to help get you started. OWASP is not meant to be a comprehensive security solution, so it's more of a training oriented, beginner oriented thing. So it's a great place to start. But CWE, again, it's a very symptom oriented solution based on the bad stuff that's been happening for the last 10 or 20 years. And CERT is more of an engineering standard based on building your software in a secure way. So we see these three probably the most. And in fact, we commonly encounter organizations that are running OWASP and CWE. That way, their clients, their partners, vendors, supply chain, everybody can say, here's what I'm doing for this particular standard. So you're kind of ready to go. So as I mentioned before, the elephant in the room is really API security, right? And we hear frequently and constantly that APIs are like puzzle pieces. And it's my least favorite analogy because I feel like they're more like Lego. And the reason I say this is that puzzle pieces, generally speaking, can only be put together in one way. Now you can sort of mash them together, but it doesn't produce a useful output. Lego, on the other hand, you can put it together in some way that's horrible, or if you follow a certain set of instructions, maybe you built a Lego car or a Lego rocket, right? And that's how APIs work. And the funny thing is that when someone builds an API and releases it publicly, they might intend that you're going to build a car, but Wilhelm and I decided that we want to build a rocket using that same API. And so these unintended uses are still correct, valid, and not malicious, but they can cause issues because they weren't part of the original design. And we've already seen for more than a decade now that API testing is a complicated space. If you look at this risk matrix I've created in the bottom left, application testing is something we understand. I won't say that everybody does it well, but we know what we need to do good application testing. API testing, if you move up on the top left there, requires a deeper knowledge of the code because I have all these little pieces and I need to understand not just how they're being strung together, but how they might be strung together in other ways, right? And how they're protected. So it takes a lot more skill, and we see that frequently people who are used to just doing UI testing get stuck when they have API testing tossed at them. Security testing on the bottom right, similarly, like you might be really good at application testing, but unless you understand what can go wrong and how it can be exploited, why a buffer overflow matters, why allowing people to put funny characters in a web form matters, why leaking data when you have an error message matters. Until you understand how people break in and what can happen, it's really hard. So it typically requires special training and special tools, some really cool tools out there. And so when we get into API security testing, it's like the most dangerous area because it requires deep knowledge of the application, knowledge of the code itself, how it's built, how the application's used, what are security possibilities and ramifications, what are the tools that help me drive it. And so it becomes an area that is obviously underserved, and we see that in the reports that I referenced earlier. So there's a couple of things that people do typically for security testing, and in particular API security testing. One is called static analysis, or static analysis security testing, or SAST, right? And this is very white boxy, right? We look at the code, we analyze the code, we have a lot of really deep information, and it can happen really, really early, because right as you start writing code, you can start to get information. What it can't do is look really at the user layer and the user experience. And so we know where a problem is, or where a piece of problematic code is, a weak piece of code is, but we don't know how to trigger the particular event. Dynamic application security testing, or DAST, or pen testing is one of the types of dynamic testing, is really outside in, right? It's black box. It finds real bugs. It knows exactly, here's what we did and here's the bad thing that occurred, but it doesn't know where in the code it occurred. It doesn't know where the problem is, why the problem happened, and it might not know if the problem got logged, or in some cases you can subvert an application in a way that the UI doesn't see it, right? And so there might not be an indication. I might be triggering a problem. So both of these forms have their strengths and weaknesses. You should be doing both of them. I mentioned earlier there's a security standard called the OWASP Top 10. There's also one called the OWASP API Top 10. It's less well known, and it's, let's say, semi-official. Okay, it doesn't have the same blessing that the OWASP Top 10 does, but it's out there with the OWASP group. And it has 10 things that typically happen in API, and it has issues around, you can implement it from a SAST perspective and a DAST perspective. So, we've done some pretty cool things where our static code analysis can implement the OWASP Top 10 or the OWASP API Top 10. We can do it in SAST. We can do it in DAST, and we can actually take the security threat models that are in various tools and apply them to your existing tests, so you don't have to be a security specialist in order to execute the security tests. You still need to understand what you're doing in terms of looking at it, interpreting it, and fixing it, but you don't have to be an expert in order to start doing more security testing. So it's really cool. So with that, I'm going to hand it back to you, Wilhelm, and we can take a look at some more cool stuff.
All right. Thanks, Arthur. Let me get that screen share up.
And
all right.
while he's doing that,
you see it.
if you have questions, again, make sure to put them in the question box. We'll be happy to answer them. All right. I see you.
Right. Perfect. So in the next part of this presentation, I want to get into some of the remediation workflows and how you can really get set up to see that end state that we covered earlier, and also talk more about API security. And so, as Arthur mentioned, there's SAST, there's DAST. So I'm going to start with SAST first, and here I've got our test configurations up. This is basically where you define, what is the rule set that you really care about, right? And if I pull down on these categories here, right, here's CWE 4.5, right? As this gets updated, we pay attention to that. Right here, we've got DISA STIG. Further down, as Arthur was talking about, there's the OWASP API Security Top 10, which came out in 2019. And then we've got two versions of the OWASP Top 10, right? The one from 2017, the one that came out last year, PCI DSS. Right here is CERT that Arthur was talking about. So lots of standards to choose from out there. And depending on your industry, there may be one that's more appropriate than the other. So these are all great starting points, I would say, right? And here, what we're looking at right now is one for DISA ASD STIG. And notice that here our checkers are named after the specific rule in the standard. So there's no cumbersome mapping really required. You can pick one right here, protect against SQL injection. And right, we know the STIG ID, right? Application must protect audit information from unauthorized modification. So this checker maps to this STIG ID 1290. And with each checker, we've got really detailed documentation, great for developers, security experts, architects to come together and decide, which of these checkers are important for us. What do we turn on? How do we configure them? Many of them will have parameters that you can tweak based on the project you're working on. And of course, we have example code, right, that shows the problem, example fixes, and for a lot of our checkers, additional education and training, right? So videos, from some of our partners at University of Wisconsin-Madison on security topics like SQL injection, or another of our partners, HackEDU. Then, of course, references, right? Where is this coming from? Well, all over the place, right? OWASP, CWE, PCI DSS. Everyone talks about SQL injection because after so many years, it's still an issue. It still happens all the time. So it's still an important Severity 1 thing to look at. So now if I come back to the dashboard here, that's the configuration, right? That's sort of the first step. Decide what you care about, start scanning your code. But once you do that, right, you saw earlier that we've got over 5,000 of these findings that we're catching. So what else can we do for teams that are ready for remediation to start addressing this in a logical way? And so here's where some cool analytics come in, like violation hotspots, for example. So here, one of the interesting things about static code analysis, and specifically there's a type of static code analysis called data flow analysis, where we're symbolically executing the code to kind of find various weaknesses or bugs. So there's a starting point and an ending point, right? And all the paths through your a typical code base could be billions, trillions, right? More paths than you could really imagine. Um, and so these tainting points, there can be intersections through multiple findings, right? And so here we've got 196 different findings across different checkers that we've got. They're all intersecting where there's the tainting point, right, for this data is JDBC admin DAO line 81, right? So if I were to drill down into the specifics here, we're going to get presented with the source code to see, what's the particular issue. But we have these traces where you can come in, and we have 100, almost 200 examples of this where we have different findings, right? Here's the point where the data is getting used, but the tainted data, it's all coming from this line 81, right? So you could address this issue at its source, line 81 here, and knock out 196 findings in one go, right? So these violation hotspots can be a great analytic to chop down the numbers quickly, right? As you're looking to comply with a particular standard, or even whatever configuration you've decided is appropriate for you. Um, so let's see what's next. Most tools will have the concept of severities, right? So here we have severity 1 through 5, 1 being the most critical, 5 being informational. But with some standards, you also get additional risk profiles. So if I jump to a dashboard here I created for CWE that covers some additional things, we can see that the CWE standard comes with technical impacts, right? So out of all of those checkers that we've enabled, we have these technical impact categories with violations associated with them. So read data is the worst category our Parabank project has, right? Bypass protection mechanism, modify data, etc. And there's these different ways of slicing and dicing the data here, right? Data neutralization issues, CW 137. And CWE is kind of interesting because they have a certain hierarchy of categories and sort of lower level weaknesses that kind of sort of map to each other. And so we've kind of pulled that apart to give you this ability to look at these different vectors, you could say, into the findings. And maybe, right, cross-site request forgery is something the team wants to work on all at once and clean up a category in one go. You can get all the findings for that and start assigning them and working them that way, which is quite nice. Now, coming back here, the next thing, we also take things to the next level here. Let me come back to this dashboard with AI and ML. So at the bottom here, I've got a fix action AI ML prediction widget. And so what this means is we are applying machine learning workflows to help teams efficiently filter out kind of the soot from the diamonds, right? And figure out what they should really be focusing on versus maybe what they should be suppressing. So if I come to the Violations Explorer here, basically what we've built is the ability to train a machine learning model. Right? And so if I talk about how that training works, basically you can take the build history, right? So as you adopt static analysis with the team, uh, developers are going to be fixing things. They're going to be suppressing things they feel is like noisy or unimportant. Right? You run your build. We get the results. Fix some more stuff, suppress some more stuff, run another build. So over time, we're training the model on, right, the developer's behavior, right, what they care about, what they don't care about. Or you can always classify violations by hand, right? If you want to get started with machine learning right away, right, we'll give you 20 violations. You classify them for us, and we'll start working on building that model for you. So you get the model to a level where we're going to give you good predictions. We can predict those actions, and as a result, um, right, we get some violations. Out of the 5,000 that we've got, we can drill down into um, you know these specific findings here that will you know we should focus on these first, right? These are the most important ones um, that we should work on. So the next thing I wanted to talk about is penetration testing results and a bit about how Parasoft's continuous quality platform enables developers and QA to adopt the practice, even when they might call themselves security novices, right? As Arthur referenced from that Imperva report, API insecurity has a high cost, And we know that API security testing can be especially difficult. So um, let's drill down here and take a look at our API security report. So from the main dashboard, here I'm looking at OWASP API security issues. So there's one A5, one A7, HTTP verb tampering, pretty interesting. So if I drill in to the test that kind of triggered this finding, this is coming from our functional testing solution, SOA-test, where we run API tests functionally, actually load and performance, security as well. And so here we've got a post request for bill pay where we ran some pen tests and say we want to look at this HTTP verb tampering here. So for all of the findings, we get right a risk factor, confidence factor. What is the CWE ID? What are the OWASP IDs? A description of the problem, right? A solution. So what should development do about it? References, of course, and traffic, right? So these are API tests. So we can see here's the request, here's the response. And so basically what HTTP verb tampering does is, typically, right, HTTP verbs, you'll see get, post, put, delete. And so here we put a nonsensical verb and, right, the server isn't handling that properly, right? And so uh, there isn't the right input validation set up with the API, and you could be exposing sensitive information to a hacker, right? Look, Apache Tomcat 8570, that's not something you want anyone to really know about your API, right? And it's all because it barfed, right? It didn't know how to handle a scenario where we're sending in a nonsensical HTTP verb. So uh, makes a lot of sense, right? Why you'd want to not just focus on SAST, right, and making sure that the code is well written, but also trying to break in from the outside, right, and make sure that you're plugging those holes as well. Um, so what makes it really possible here for development and QA to adopt API security tests within their pipelines is this component that I described from our continuous quality suite SOA test. Um, Being a no-code API testing framework that app teams leverage for their automated API testing, they'll use it for functional testing, component testing, regression testing, end-to-end testing, load and performance, and of course, security. What this means is teams can reuse the test assets that they're already running for, say, functional testing, and then enable penetration testing with the click of a button. So SOA test comes bundled with OWASP ZAP, and it provides a seamless mechanism where testers can kind of correct, or rather, they can use their application domain knowledge to start performing security testing that might be outside of their skill set, right? You know your application well, you're testing the APIs, but you may not know security very well. We can start bringing security testing earlier in the cycle, right? Shift left. And this ends up delighting both security teams and upper management because the end result is you start getting higher quality builds where your security team starts finding less issues and ends up becoming a less disruptive force in that release train to production, right? You never really want to get through all of your cycles only for AppSec to find a bunch of issues that need to be remediated, and it slows down your progress towards release, right? That's real frustrating. So anything you can do to bring in the security practice earlier into the application development lifecycle, and find some issues earlier, the better off everyone's going to be. So that's kind of what I had to show. So Arthur, I'll pass it back to you.
Cool. I wanted to just hit on a couple of those things that you were talking about, and then we'll take some questions, Wilhelm. So, we saw there, obviously, knowing where you're at is interesting, but at the end of the day, you have to fix what you found, right? There's no sense doing security testing and then not doing security fixes or patches or whatever. And security tools have a well-deserved reputation for producing a mountain of stuff. I call it soot. It's the information that comes straight out of tool, SOOT, and it's like a pile of coal, right? And what we're looking for are the few diamonds, right? What are the important, useful things that I need to fix, and what's the stuff I can safely ignore? And there's some steps that we use to help minimize that, and Wilhelm showed them to you, right? Number one is configuration. What is the standard that I'm running? What are the checkers that I'm turning on? Am I turning on the things that matter to me for my needs today? Another's the severity. Again, all static analysis tools typically have severity. We can actually allow you to adjust them. So if you think something is more or less severe than we do, then you're free to alter that. So that helps as well. We've also implemented the risk models in various standards. So we saw that we have the technical impacts, for example, from CWE. OWASP has things like the regularity of the problem, how frequently it's occurring in the field, how hard it is to get into. CERT has things like the cost of remediation. So they all have very interesting pieces of information. We've actually implemented them directly into our reporting so that you can see them and use them. And then as Willem was showing you, we have an AI/ML that actually does the next step. It's the first phase of triage. Then is that the AI and ML looks at what you've been doing either through manual training or through historical usage of your tools, and then starts to tell you that, hey, these findings are ones that you're going to want to fix, and these are ones that you can avoid because you always avoid them. And so the AI model has some pretty interesting information about static analysis violations that help it make those determinations, not based on its ideas, but based on what you actually do. So it's an extension of your team. And ultimately, you've got some human review, but the goal is to minimize that number and then use some of those AI augmentations like the hotspot, where Wilhelm had a single line of code that was affecting almost 200 violations. So one fix and 200 things go away, right? Like that's where you start, right? A critical issue that's got a good hotspot, and off you go. So very important things to implement. I did want to just make one further little thing about risk, right? Because not all security findings are equal. And so a couple things from these standards. CERT takes into account severity, likelihood, like how likely is it that this piece of code could lead to an exploitable vulnerability, and then cost, right? Cost being amount of effort, manpower, time. And they put it in this cool little like dartboard, right? Like the nasty stuff's in the middle and you start there, right? So we've implemented that. OWASP has this risk model with the 2017 talking about exploitability, prevalence, detectability, things like that. We've taken it one step further with our own unique widget that puts it into a security matrix, a risk matrix, so that the intersection of, for example, of things that are easy to exploit and are widespread becomes your most dangerous box. And so you'd start in that bright red upper right corner and fix those items first. So it just helps you get where you want to go. We talked about technical impact. These are these little blue boxes in the top left. This is ISO 25010 or 27010, helping you decide these are the things that can go wrong in software, and so we can put them into buckets and you can start to understand. So we've taken that information from CWE and passed it along in your report. So if you're worried about security or reliability or maintainability, you can focus on the most critical, most risky issues that have that kind of an impact. So it's kind of unique in that sense that we have done that. So we're not a pure security company, I don't believe that security is orthogonal to the software process. I think that if it's only done late cycle, that it's going to be problematic. Wilhelm mentioned that nobody wants to do a bunch of work to build an application, then have a security team come in and complain that we need to all start over, right? Security and quality need to go together, and that's why you do static analysis, not so much to find bugs, but to find potentially weak code that's going to get triggered later on during the dynamic testing. So if I can build better code, I spend less time responding to security findings that are late cycle. So, typically, if you're doing static analysis for quality or reliability or safety, just add the security rules to it. And in fact, a lot of them overlap. A lot of them are the same kinds of issues. Memory corruption issues are also security issues, right? Data overflow issues are also security issues. So making your application more secure is also making it higher quality. So we work all throughout the life cycle. We have different tools that help out in all these different areas: unit test, regression test, integration test, UI, penetration testing, etc. We can make it really, really easy to do these things, and you can certainly try them out. We have a variety of tools. We have specific language tools for doing deep code analysis: C, C++, .NET, Java. Again, unit testing tools that have some AI augmentation as well to drive deeper coverage, service virtualization to help decouple yourself from things that are impacting your testing or impacting your ability to do CI/CD. API testing, as we talked about, functional testing, UI testing, etc. So lots of cool stuff that all work together as part of our continuous quality platform. So the tools can talk to each other, can learn from each other, can share information with each other, and then the data results all get rolled up together in these unified dashboards that Wilhelm has been showing to you. So there's a couple of different URLs here. Take your smartphone and point it at, and you can click it and go to this. But we've got a blog post here about various secure coding standards and the approach of using static analysis to enforce standards. And then a webinar that I did with Sandy Corelli from Forrester Research about using the API top 10, OWASP API top 10 in static analysis. So it's kind of a fun little thing. So with that, let me check the question box here, and we have a few questions, Wilhelm. So one of the questions is, are the Parasoft solutions able to be containerized to support dynamic DevOps and CI/CD platforms?
Yes.
Yeah, we actually have lots of customers doing this, and it's kind of a normal way. People run static analysis on the desktop so that you're doing things ahead of time, and then you run it in the CI/CD to make sure that the integration of everything everyone's doing together is done, and use it as a gate at that point. So yeah, and Kubernetes, etc. And we support all the big cloud platforms, AWS, Azure, etc. Here's one says, I manage our application development sector. Is it possible for Parasoft reporting and analytics to track current security state for all my projects?
Yeah, so that was part of the kind of first dashboard I showed when we first started the demo. You certainly can set up a dashboard for that purpose, right? If you've got a portfolio of projects, whether it's 10, 20, or 100, you can kind of track the state of security across those projects or programs kind of in one unified way.
Yeah, and you can even, as we mentioned, it can be quality and security. So whatever the tools that we have are there, right? We can take into account the manual testing, the coverage, the unit test, the functional test, the API test, the static analysis, the SAST, the DAST, and roll it all together for multiple projects and make a glorified, unified view that's a single statistic, red lights, green lights, as we saw on some of the charts. Or we can make something that's only focused on coverage across the portfolio, or whatever. All these widgets that you saw Wilhelm used, like they can be mixed and matched. We have a bunch of out-of-the-box reports that he relied on, and a few that he created on the fly. So it's all, an extremely flexible reporting platform that allows you to take in data and combine it in ways that are useful to you and do some interesting analytics. How often do you update support for different standards? Well, that depends on how often the standard updates, right? OWASP is I think that officially they're every 2 years, but in practice it's every 3 years or every 4 years. CERT is kind of a regular minor updates thing. CW is very similar. We get a lot of incremental growth in the standards. The CWE top 10 is every few years. So we just, when the standard updates, we try to update. The interesting thing is that, again, the top 10 lists kind of change in terms of what's going on in the world today, but the actual underlying standards are, software is software, and the problems that we make are still the problems that we make. They're not going away. So what we get is a couple of new things, but even those are, there's not a big flood of new ways to break software, right? There's a big flood of new symptoms constantly. But when you look at the code, like the code is the code. And just because you found a new symptom, it's still like, uninitialized variables or not checking inputs can manifest itself in literally hundreds of ways. Whether it's cross-site scripting or SQL injection or whatever, right? But it's, at the end of the day, it's tainted data, right? And so, not validating data is, a massive problem. It's not SQL injection. I'm happy to say, Wilhelm, like in the past years, SQL injection was number one, and it's not anymore. So I'm happy to see that it's not number one, but I'm less happy to see that it's not so much that injection has gone down, but it's more because other things have gotten more prevalent. The numbers of SQL injection are kind of flat, just the other numbers are growing faster. That's sad. Anyway, with that, we're happy that you could all join us today. Feel free to watch some of these things. Again, they'll be you'll be getting a link so that you can watch this and share the link with your friends and they can watch it. If you've got questions, send them to info@parasoft.com. We're happy to answer them. If there's a specific topic that you'd like to dive deeper into, please let us know. We're happy to add it to the webinar series. And go check out some of these other things, or actually just go get a demo, right? Like, check it out yourself. So thanks, everyone. Have a great day. We're glad that you could join us. Bye-bye.
Thank you.